Welcome students. Now in this video we are going to see some of the numericals on this electrodischarge machining. Let us take the first. So see here, during the electrodischarge drilling of a 10 mm square hole in a steel plate of 5 mm thickness, the brass tool and kerosene, this is the dielectric fluid, is used. The resistance and capacitance of RC circuit are 50 ohm and 10 microfarad respectively. The supply voltage is 200 volt and the gap is maintained such that the sparking takes place at 150 volt. Sparking or discharge. So estimate the time required for the drilling operation. Okay, so let us solve this question. This is on electrodischarge machining. So what are the given terms? There is a drilling of 10 mm square hole. The square hole, how much it is? 10 mm, and depth of the hole, that is thickness of the plate for 5 mm, that is 10 by 10 by 5, that will be the volume of material removed, isn't it? So what is this volume V of the material removed? That is 500 mm cube, isn't it? So next, the resistance is how much? Is 50 ohm and capacitance is 10 microfarad, so into power 10 to the power minus 6 farad, and we are having the discharge voltage is 150 volts, whereas the supply voltage is how much? 200 volt, isn't it? So these are the given data. Now we know that to find out the time required for the drilling operation, see here, very simple basic thing, please keep it in mind. So here see, we are having the material removal rate. रेट बोले तो क्या? पर यूनिट टाइम, दैट इज से मटेरियल रिमूवल रेट किस में आता है? mm क्यूब पर मिनट. ओके, सो इफ यू वांट the time required for the drilling operation, whatever the drilling of 10 mm square hole with the depth 5 mm. So for that, how to find out the time? It will be the volume of the material to be get removed from this plate in form of square hole. Volume of material removed divided by what? The material removal rate. Material removal rate. Now you can do that. If you do the dimensional analysis, then it will be mm cube divided by mm cube per minute. So your answer will be in minutes. Okay, so very simple. So please remember this thing. So just same thing we are going to do in this question. Because we are knowing now the volume of material to be removed from the plate is this much. Now we are interested in the material removal rate in the EDM, that is Q. And how this Q is given in this EDM? We know that it is 27.4 into P to the power 1.54. It is in mm cube per minute. So for that we should watt this power in kilowatt, so that we put this value here and get the Q and put here, so that we can get the total time required for this drilling operation. Let us do that. So we know that power कैसे निकालते हैं EDM में? P average is equal to what? This energy divided by this TC plus TS. But TS is negligible and nothing is mentioned about this sparking time. So we can write this equal to E divided by TC. And energy कैसे निकालेंगे फिर? It is energy released per spark, that is half into C into V D square. So put the values. Half into capacitance is how much? 10 into 10 to the power minus 6 into discharge voltage is how much? 150 volt. So if you get the value for E as 10 into 10 to the power minus 6 into 150 into 150 divided by 2. So it is 0.1125 joules. So this is the energy we got. When charging time, it is R into C natural log to the base E, that is supply voltage divided by supply voltage minus discharge voltage. It will be in seconds. So calculate. R is how much? So R is 50 into C is 10 into 10 to the power minus 6 into log to the base E. Supplied voltage is 200 divided by this 200 minus 150, that is 50. So we can calculate 500 into e to the power minus 6 into ln of 4. How much it is? It is, say, 6.9314 into 10 to the power minus 4. Okay. So you get here the value of Tc, then you have the value of this energy released per spark. This is charging time. So put here, you will get the value for the power, that is energy is how much? 0.1125 divided by Tc is what? That is, I can write directly 6.9314 into 10 to the power minus 4. So you do the calculation and tell me the answer. So 0.1125 divided by answer, I will get this P average as 162.3 watt. Okay, so see here whether I am doing correctly or not. Now once you get the value of P, find out this material removal rate. Q is equal to 27.4 into power in what? Power in kilowatts. So it is 162.3 watt. So 0.162 kilowatt raised to the power 1.54. It will be in mm cube per minute. So if I calculate this Q, then 0.162 to the power 1.54 into 27.4, it will be 1.66 mm cube per minute. So this is the MRR you got here. And to find out the time, we know that is material removed from the work surface on plate, that is 500 divided by the material removal rate per unit time, that is 1.66. this will be in minute. So 500 divided by 1.66, 500 divided by 1.6, this is 300.9 minutes or 301 minutes. So this will be the time required for that drilling operation. This is the time for the drilling operation in minutes. I hope it is clear. Very simple. If you know the formulas, very simple. We'll take the next example. Definitely. A resistance capacitance circuit, the RC circuit, I will write in short. As used in EDM, the discharge voltage is 100 volt at a spark cycle time of 25 microsecond. The average power P average is 1 kilowatt, it is given. The capacitance in microfarad they are asking. Option A 2.5, option B 5, option C 7.5 and option D 10. This is GATE ME 2015 question for 2 marks. So see here, the resistance, capacitance and relaxation circuit used in the EDM process. The discharge voltage is how much? 100 volt. So what is given here? Discharge voltage 100 volt and spark cycle time TS is given, which is 25 micro, that is 25 into 10 to the power minus 6 seconds, isn't it? And average power is how much? 1000 watt, isn't it? The capacitance, okay, the value of C they are asking. The value of C they are asking. We know that power is equal to what? Power delivery will be energy release per spark cycle divided by cycle time, that is TC plus TS. So here nothing is given for the TC or no any data, sufficient data is given for TC, so you can neglect this. So what will be your formula? That is energy per unit of sparking time. So what is this power? Power is 1000 watt into TS how much? 25 into 10 to the power minus 6 seconds is equal to, we know what is energy release per spark in the EDM. It is half into C into VD square. You know E is what? Half C into VD square, that is discharge voltage square. So C is unknown here, VD is given. VD is how much? 100 square. Okay, so if you solve this, say C will be how much? Calculate this. So 25, that is 50,000 divided by 100 divided by 100. So it will be 5 into 10 to the power minus 6 farad, but they are asking in microfarad, so it will be 5 microfarad. So see the option which is correct. So yes, option B is correct. Okay, very simple. Again we will take one more example. See this very easy GATE question. So see here students, the next example we have taken for this EDM. This question asked in ME 2018 for 2 marks. Let us see what is given. See, read it. A circular hole of 25 mm diameter and depth of 20 mm is machined by the EDM process. The material removal rate in mm cube per minute is expressed as 4 into 10 to the power 4 into I into t to the power negative 1.23, where the current is 300 ampere, melting point of the material is 1600 degrees centigrade. The time required for machining we have to calculate. Okay, see here. So first of all, the material removal rate is, the empirical relation is given directly. So let us calculate that. Say the MRR, which is equal to 4 into 10 to the power 4 into current is how much? 300 ampere. 300 into temperature what? It is in degree centigrade. So don't worry, 1600 raised to negative 1.23. So calculate how much it is. So 1600 to the power negative 1.23 into 300 into 4 e to the power 10. So it will be MRR will get 1374.40. It will be in what? Mm cube per minute. So Q you got here, and what is the circular hole? Okay, the plate is there, of course, plate is there. We have seen this question before, but instead of circular hole there was a square hole. Here the circular hole, and depth of plate is how much? 20, that is 20 mm is the depth, that is thickness of the plate is given, and 25 mm diameter. So phi is here 25 mm. So of course the volume of material removed from the plate is how much? From the plate is equal to what? Pi by 4 into say d square into h. D is the diameter of this hole and h nothing but the depth of the plate, that is pi by 4 into diameter 25 square into 20. Calculate this. So 625 into 20 pi divided by 4 is correct. 25 square into 20 pi divided by 4. So it is how much? So 9817.47, it will be in millimeter cube. Okay, so very simple. Again, you know how to calculate the time. Then time will be what? This volume removed, that is volume of material removed from this workpiece or plate, divided by this sorry, the volume of material removed from the plate divided by Q. Very simple. That will be what? This 9817.47, this will be in mm cube, divided by rate, how much? 1374.40 mm cube per minute. So how much it is? Divided by 1374.40. So it will be 7.143 minutes. So how much time required? So the answer will be 7.143 minutes. Let me check whether this is correct. Yes, it is correct. 7.14 is the answer. So how much time required? 7.14 minutes. So see, this is how they are asking the questions on the EDM. Okay. So dear students, let us discuss the next question on this electrochemical machining. See what is given. In ECM operation with the flat surfaces, a 10 volt DC supply is used. The conductivity of electrolyte is 0.2 ohm inverse second inverse, and feed rate of 1 millimeter per minute is used. The workpiece of pure iron, and the properties for that iron is given, density, valency and gram atomic weight is given. Calculate the equilibrium gap. Okay, and ore voltage we have to consider to be 1.5 volt. Let us solve this. So we know that the equation of dynamics for the ECM we have already derived, that is this feed rate or change in gap, this dy by dt is equal to lambda by y, isn't it, minus this feed. So here as we are going to find this equilibrium gap, if this gap equilibrium, that is this y will be replaced by, you know, y e, and this change in this gap per unit time will be 0. So what will be our equation? That is lambda over ye is equal to f, or ye is equal to lambda divided by f. What is our lambda? We know what is our lambda, that is k into a into v minus delta v divided by rho f z. This is our lambda, we know this, into this feed rate f. Okay, so I hope this conductivity is given, the gram atomic weight A is given, supply voltage, over voltage, density, Faraday's constant we know, valence is given, feed rate is given. So definitely we can able to calculate this equilibrium gap YE, which is equal to, put the values, YE is equal to K is how much? 0.2, and as I taught you, please use the CGS unit for solving the questions on ECM, because we have taken all these formulas based on these CGS units. So gram atomic weight is how much? 55.85 gram, into bracket supply voltage 10 volt minus over voltage 1.5 volt, divided by density in grams per cc 7.86, into valency into Faraday's constant 96500 coulombs per mole, into valency is 2, into feed rate, किसमें दिया feed rate? 1 mm per minute. Now 1 mm per minute, that is how much we want in centimeter per second, isn't it? So 1 millimeter, that is divided by 10 centimeter, that is 0.1 centimeter divided by second, that is 60, isn't it? So let us calculate this. That is 0.2 into 55.85 into 8.5 divided by 7.86 divided 96500 divided by 2 divided by 0.1 into 60. So it will be how much? 0.2 into 55.85 into 8.5 divided by 7.86 divided by 96500 divided by 2 divided by 0.1 into 60. So it will be 0.0375. So nearly I will take 0.04 centimeter. So this is our answer. So what is the equilibrium gap? कितना आया? 0.04 centimeter. Let me check. Yes, it is correct. 0.04 centimeter. So let us take the next question. See, in ECM process with the pure iron workpiece, a removal rate of 5 centimeter cube per minute is desired. Determine the current required. Okay, so here ECM process is there and we have to determine the value of current, and for iron the values for density, gram atomic weight and valence is given. So we know that the material removal rate, actually this removal rate, that is MRR, which is Q in the ECM given as this gram atomic weight into current divided by density of the anode, that is workpiece material, into F into Z. F is Faraday's constant and Z is the valency. So here Q value is given. Q is how much? 5 centimeter cube per minute, and we know we need the CGS unit. So Q I will write in terms of, say, 5 centimeter cube is okay, but divided by minute. So I have to take it into seconds. So 5 divided by 60, that is centimeter cube per second, is equal to A 56 into I is unknown divided by density 7.8 into F 96500, we should know the value, into valency. So if I calculate, what I'll get, let me calculate, that is 78 into 96500 divided by 60 divided by 56. So it is 2240.17. 2240.17, it is correct, 17 amperes. So this is the value of the current, this much current will required in this process. Okay, so dear student, let us discuss this last question on this electrochemical machining. So the surface irregularities of the electrodes are 5 micron and 8 micron. These are heights of the peaks of asperities as shown in the figure. If the work is pure iron and DC voltage of 12 volt is applied or employed, estimate the largest possible feed rate which can be used. In this case, take this conductivity of electrolyte K as 0.2 per ohm per centimeter and this ore voltage as 1.5 volt, and these properties for the iron are given as density 7.86 grams per cc, gram atomic weight 55.85 grams, and the valency as 2. So of course here are the peaks of asperities are given for the work surface and electrode surface, and we have seen this. In this case, what we have to take the nominal gap as, and this nominal gap is what? Allowable nominal gap between the two electrodes, that is work and tool, as what? The peak values of this work surface as well as from the tool surface. The summation of this, that is 8 micron plus this 5 micron, so that is 13 micron. So it is micron, so converted into centimeter, so it will be 0.00013 centimeter. Very simple. And that will be our what? The equilibrium gap, and this will be our equilibrium gap. And we know how to calculate this equilibrium gap. This YE is equal to K into A into bracket V minus delta V divided by rho Fz into this F. So here they are asking for this feed rate. Definitely feed rate in centimeter per second. So this feed rate we can write F is equal to this K is how much? This is 0.2 into A 55.85 into V minus delta V, that is supplied voltage is how much? 12 volt minus ore voltage 1.5 volts divided by density 7.86 into F 96500 into valency 2 into equilibrium gap is how much now? 0.00013 centimeter, isn't it? So let us calculate and tell me the answer. So it will be into 0.2 into 55.85 divided by 96500 divided by 7.86 divided by 2 divided by 0.00013. So it will be 0.6 or 0.59. So please here it in centimeter it will be 0.0013. Please remember, oh, sorry, 0.0013 centimeter is there. Okay, so if we have this value, then feed rate will be 0. How much it is? 0.059 centimeter per second. Okay, if you want to convert it into mm per minute, then it will be 0.059. So 10 centimeter is equal to, sorry, 10 millimeter is equal to 1 centimeter. So into 10 millimeter into, for minute 60 minutes are there, into 60. So it will be in mm per minute. So this will be the feed rate if they are asking mm per minute. So how much it is? So into 60 into 10, 35.68 35.68 mm per minute. So this will be the feed rate. Very simple. See how we have done it. Thank you so much.